title From Bipeds to Human Robot Applications. And this is my advisor, Professor Ichiro Kato. Unfortunately, he died in 1994, but he started human robot research, I believe, for the first time in history. The left one is Robot 1, which stands for Waseda Robot number 1, like this. This is very a large robot, and this robot has 2 legs, driven by hydraulic power. But the working speed at that time was very slow, about 40 to seconds per 1 minute. And the step length is about 10 centimeter. But actually this robot worked. And this robot has more function about AI, data processing and communication function with a human operator. And the right-hand side, 10 years later after this, robot was developed to play the electric organ like this. This robot is a sort of prototype of human robot called Waseda Symptom robot, which played the keyboard play in front of the public next year in 1985 in Tsukuba Expo 85. And Professor Ichiro Kato started human bipedal walking robot research from 1967. In the beginning, just one type, and then he gradually combined to the type and building up a humanoid type to this called Wabian. And I can show some demonstration of the robot. Okay, on the left-hand side, this is when I was a student, PhD student, the robot worked like this, driven by hydraulic power. On the right-hand side, after my graduation of PhD course, I developed a human bipedal robot like this, but what the robot stabilization is mainly done by the upper body like this. And then this is advanced type from the previous one. And the robot realized much faster working like this, about 0.5 second a step like this, but still driven by hydraulic power. And because of Professor Ichiro Kato's achievements, especially in Japan, there are a lot of researchers, university professors started the bipedal walking robot like this. And then in the middle of the 80s, those professors gathered and published a sort of booklet like this. And then, unfortunately, Professor Ichiro Kato died. I started, still continue the human robot research like this. The first one is Wabian type 2. The point of this robot is a mechanism on the pelvis, which enable the robot to walk human-like, meaning that the robot can fully extend the knee while walking. And also the mechanical design of the robot is about the same as human anatomy, such as the ratio of the limb lengths of the arms and the legs. And the height is about 150 centimeter, but a little bit less than Japanese females average. And you can see the robot can walk by fully extend the knee like this. The knee pelvis is moving while walking. And if the surface is relatively smooth, the robot can also walking on the outside like this. And this is a point of the fully extending knee walking. This is a human measurement result. especially the vertical component of the flow reaction force has two peaks. So this Wabian 2 can do the same thing like this, while Wabian 2 bending the knee, still there is no peaks like this. And after that, we try to make the robot work with even human-like foot, like this, feet. And we also collaborated with, at that time, Hitachi and several other companies because Fabian 2 can work human-likely, and degrees of freedom is very small, similar to humans. So in this case, Hitachi was developing a sort of robot device in order to support the elderly or handicapped people to work outside. We used this robot as a sort of robotic dummy door. And also we working together with a researcher in human science because Waseda has the human science school in Tokorozawa, and we measure the motion the handicapped people, and then we try to copy the motion to the human robot. Okay, and also this is the a sort of social testing. Like this, we put the robot on the public road, how in order to know how the robot perform or how the robot could work. And then Professor Paolo Dario invited me to join the FP7 European very large project called the Robosom in the middle of the 2008 or sometimes around this. And we enjoyed very much the collaboration, and our technology was used not only within the university, but also to many outside organizations, private companies, including Sony. And we also started the development in the beginning of 2000. And this is a demonstration video by carrying the many people in the US, Los Angeles, like this. Okay, my young colleague, Dr. Otani, is now challenging the biped robot to skip like this. And he is trying to make a more human-like one like this. And we also help to develop a robot educational kit like this. This is a sort of small Segway. We called it Miniway. And a small company started to sell this kit about 10 years ago, perform many other motions like this. And as well as the rapid walking robot or human robot, we started human robot musical player robot like this because Professor Ichiro Kato developed a keyboard playing robot. And I started the flute player robot like this. And also we needed to collaborate with a professional flutist, and he taught me a lot of things. And this robot has two lungs like this, which mimics the human lung, meaning that the robot needs to breathe. And also this robot is using mainly the lips, changing the shape of the lips. And then robot realized this kind of very good performance. Okay, for the fruit play, the robot first, before playing, the robot tried to search the best position between the fruit embouchure hole and the robot lips. I don't have time to go into the detail, but this robot actually tries to make this performance index to be maximized. And also we started saxophone player robot like this. It's a collaboration research with the Toyota Motors. And this is okay. And then we started to develop a speech production robot like this. Okay, I believe you still can see the video. Okay. Yeah, this is a demonstration of vowels, a, u, e, o. And for example, sashi, suse, so this robot needs to have a teeth. Okay. Tachitsute to. Okay, and papi pupepo, this robot needs to be airtightness. Mechanism of the robot, we employ the sort of wire-driven mechanisms in order to change the shape of the lip, shape of the tongue like this. It's a big contribution from Ken Salisbury, and this robot finally successfully made a speech. And then we also developed a sort of emotion expression robot called Aicha at that time. This robot is a sort of upper human robot. And then this robot has many sensors and many moving parts, especially on the head like this. And the control, base control of the robot is determining the emotion depending on the change of the internal state and the external information by using the many sensory organs. And then we, sorry. Yeah, we especially invented, it's not invented, just a borrowing idea of equations of motion. And the totally same form. But I changed the name from equations of motion to equations of emotion. But the result was again very successful. Please enjoy watching the movie like this. This robot already ran a green ball is a good object. Okay, this robot has 2 ears in order to locate the sound source. And whenever a robot sees the red ball, robot has that experience. Then a robot got angry, but if you put vodka in front of the nose of the robot, then robot becomes drunken and then started laughing. And we continue the research with a psychologist at Waseda University, because we are very large university, having many different types of literatures. So we asked the Professor Kimura, who give us a lot of advice in order to develop the emotional robot like this. And not only the control of the robot mechanical design is important like this, because the robot can move almost human-likely. And then we combine the variant biped human robot and emotion excel robot to human robot called Cobian.
続きまして、びっくりした瞬間のマスオさん。
Maso-san is a name of a husband in a Japanese famous but very old cartoon called Sazae-san. Okay, this is another one. Because this robot can move the four limbs like human speed,
芝刈り機の真似。
the performance becomes even finer, like this. And then we started a sort of collaboration with Japanese medical university called Tokyo Women's Medical University, which is located at 20 minutes from my campus. And then I moved to the new research facility, just a neighbor of the Tokyo Women's Medical Hospital. And then this is a very old research, even before our symposium. I started as well as Professor Ichiro Kato to make a human like mastication robot like this. And after that, we also started to develop a sort of jaw treatment robot like this. There are many numbers of patients having the jaw opening problem. So we especially developed a sort of jaw opening training robot to make the jaw widely, more than former treatment. Okay, I hope. Okay, this is a demonstration of tele treatment. This is a trapezoid robot which is connected to the patient, and this is a main operator called Yamanashi Medical University at that time. And then after 45 minutes therapy, the patient could open her mouth widely, and the result was very, very successful. And then I switch back to the okay. And then after this, this is a sort of funny picture. because the mastication robot is medically treated by the jaw opening treatment robot like this. But after this, we have a very interesting idea that uh, the human robot can be used as a sort of virtual human in order to test a new therapy or former therapy. It is safe or dangerous, or how it is effective for medical treatment, or even there is a sort of you can record the any information between the master and the slave. So that data can be used for or medical education. It's like this. And then we developed this kind of robot. This is for jaw massaging robot, uh, which there are many people of dry eyes. Uh, so you have a big stress, then your eyes become dry, and at the same time also your saliva is not enough. So our medical doctors try to massage on the both side of the cheek. So this robot can do the same thing for the patient. This is demonstration video. By doing this massage, the patient becomes have more saliva after this. And we also use a sort of human-like head like this because we in the beginning we needed to measure on how professional medical doctors in oral medicine massage human. Then we try to copy the massaging motion or applying force to the robot for the robot control. And then we had an idea that uh, by our robot technology, especially on human robot, for medical education. So this is a sort of beginning stage, but actually this device is commercially available. So you see, if you try to search and literature on the, this is a not a real one, but artificial skin. Then the system measure the small deformation of the artificial skin, then display the result of the your performance. Okay, we actually employed a sort of mathematical form like this. This is on the right and left. This is a evaluation of the suture, and on the vertical axis, this is a evaluation ligature. So those people skilled medical doctors, and in the middle is a novice medical doctors. On the left side, those are master. So you can see the score becomes higher depending on the skill. And then we switch to the new project. Actually, this system is now commercially available. And we switch to the airway management education human robot like this, because we are in the collaboration research facility called Twins with Tokyo Men's Medical University, and they frequently come to my lab and check and advise us a lot of things. And then we this is the final prototype, and then we gave all the information, the prototype to the Kyoto Science, Kyoto Kagaku, and now they producing the commercial available, air management robot like this. And also we have a patent in Japan, and we sometimes give licenses to companies. So this is a Dentaloid, the Japanese famous robot company called Kenzo. And so this robot has a sort of sensors in order to check the touch inside the mouth. And also, but actually this robot is not so intelligent. So this basically the control of the robot is predetermined, and even the reaction of the robot is very controlled by professional medical doctor. But anyway, this is very useful for teaching novice doctors. And we also switched to the newborn baby like this. But a lot of challenges because we needed to make many body parts and electric parts to be small. And this is also some demonstration of the newborn baby robot. And we needed to measure many human motion. So we self-developed the many physiology sensors, including the limb motions like this. And in the middle of the research, my PhD student started, a graduated student started a small company outside. And two of my former PhD student, they graduated and started a small company called LP Research. Because they are very skilled English, so they have a lot of foreign customers. And this is a sort of demonstration video of the company. Of course, I know there are a lot of competitors, but their product is very cheap and a very good, software capability for application. And then this is a psychological research. This research is mainly done by my young colleague, Professor Hiroyuki Ishii. And he tried to realize a sort of, collaboration or interaction between robot, not the human, but this at that time rat, real rat. So we did a lot of experiment. So if the rat is hungry, the rat tries to touch the robot in order to get food. This is a sort of automatic feeding machine. Only when the robot is near the feeding machine and the rat switch on the lever, the robot, the feeding machine feeds the food to rat. And then we did another experiment like this. In this field, the field is divided by a sort of wall. And there is a small automatic door. When the rat switch on the blue lever, then the door open. Then the rat can touch the robot. Robot become closer to the feeding machine. Then a rat can feed the food. So this is psychologists told us this is a sort of two-level operant learning. I don't know about the detail, but this is a sort of famous, very interesting result of the research. And we sometimes see the very radical rat. Or in this case, the rat try to bite and drag to the feeding machine in order to get the food. And we also started the disaster capable robot after the huge disaster attacked to the East Japan, and more than 20,000 people died and missing, and many functions. And also, my laboratory was involved in the Japanese fairly large project conducted by Professor Satoshi Tadokoro. And we joined his project. And the leader of our team is Professor Hashimoto. Now he moved from Waseda to Meiji University. He continued the disaster capable robot like this. By the way, this robot is the design of the robot is based on our humanoid robot like this. But there is no upside down front and back on the side and left and the right to have a better performance in the extreme condition. And we especially developed electrical actuator like this. For the robot. And then this is just a small demonstration video of how the robot moves on the garbage like this. And this robot even the motion is very small, but the robot can go up the ladder like this. Okay, this is the end of my talk. Thank you very much for your patience.